Thanks a lot for tuning in this Hashi Talks 2024 session that I will be driving about how to build an AMI factory leveraging Packer Community, HCP Packer Registry, along with its synergies with Terraform and Terraform Cloud. My name is Sam. I'm an SAP DevOps consultant and SRE engineer within AWS. I am located in Toulouse, which is in the south of France, hence why the small French accent. I am a DevSecOps aficionado who strives to follow its practices and apply its techniques within the SAP ecosystem, and this is what I enjoy doing as part of my daily activities. So let's get started. Let's talk about motivations. Why would you ever need to build an AMI factory on AWS, and what business problems does it help solve? So it's obvious that you can't start migrating to cloud without thinking about a strategy to secure your images. So in order to set the context, I came up with some questions in order hopefully to help set it up. So the first question I always ask my customers when we talk about AMI factories is how often do you build new hardened AMIs? And in general, you will notice that the answer to this question is somewhere between once a year and twice a year, and it's clearly something where we need to improve. Second question, are the procedures to build your AMIs consistent between your cloud service providers? So the answer to this question is no, specifically if your company has adopted a multi-cloud strategy where your OS administrators not only need to know how to build OS images that are hardened as per the company security standards on premises, but also they have to know the constructs that are specific to each cloud service provider. Can you ensure that your business and application teams are running on hardened OS images at any point of time? So the answer of that is in general no, because as you know, in each AWS account, if we take AWS just as an example, each account can own its own AMIs. So if you don't implement measures to prevent that, or to allow your business and application teams to build their own AMIs, without talking about the AMIs that are provisioned as part of a backup strategy, of course, then it's going to be hard for you to track who's using what and to what purpose are those AMIs provisioned. Does your company security department provide hardened AMIs or documented procedures to mandate a security posture? So in general, the security departments, instead of providing ready-to-use AMIs that comply with the standard, they just provide documented procedures or standards in PDF files or other text documents in order to rule out security posture. And it's often delegated to the business and application teams for them to harden the AMIs depending on their OS needs. Do you have a way to communicate to your business and application teams in the event of an OS vendor deprecation, like an end of support event or a zero-day vulnerability? So in general, the answer to this question is yes, in the sense that customers can use like email notifications or Slack channels or Microsoft Teams. But the underlying question is how effective is this? Like, do really your business and application teams take these alerts into account and take action on them? I doubt that. Do you have a mechanism in place to detect OS vulnerabilities or misconfigurations before the infrastructure is actually deployed? So in general, the answer to this question is also no. We are more in a reactive than a proactive mode, which means that you first deploy your infrastructure and then you discover if the OS is vulnerable or not. So let's sum this up. Basically, there is no default inheritance of global security and compliance controls. Whatever your security department will define on their side, kind of top-down approach, will simply not be inherited directly into your different cloud service provider ecosystem. So someone needs to adapt those to each of the cloud service provider constructs. There is no control over what business and application teams run productively because you don't have that centralized oversight, and each account can go rogue and create its own AMIs. And this is something you can hopefully fix with this AMI factory. The build of the AMIs and even the management of the lifecycle of these AMIs is completely dedicated to the teams, and this makes it a layer cake with complexities to audit, to have a uniformized workflow, and misconfigurations can easily sneak in and put at risk your workloads. There is also a low degree of automations. I saw lots of customers still building their AMIs manually, like someone spins up an EC2 instance on a specific public OS. They harden it somehow, hopefully, and then they create an AMI out of it and they roll it out productively. So this is not repeatable, this is not auditable, and does not follow an elegant architecture where you make use of DevOps CI/CD pipelines. And there are no mechanisms to audit the security posture easily, which means that you cannot easily get to know if your OS configuration is vulnerable or not, unless if you install some agents or if you use some agentless solutions to do discovery on your machines. And we will be talking about that a little bit later. So now, with all of that said, what would be the proposed strategy to help fix all of these problems? So the first topic, and this is what this session is all about, which is to build a centralized AMI factory. And we will see this a little bit more in depth. But there are additional things that I'm not specifically covering in this session, but I just wanted to hint at it in here for a reference. You can also think about locking your AWS Marketplace subscription. The third element is to implement AWS organization preventive controls. Again, the objective is not to go very deep in this topic, but you can use what we call service control policies or SCPs in order to rule out in your organization that no one in the organization can use an AMI which is not coming from a specific AMI build account that you would have elected in advance. To spin up any EC2 instances, be it standalone EC2 instances or part of an auto-scaling group or a launch template in order to make sure that only hardened AMIs are being used. And you can do exactly the same with container images stored in ECR for containerized type of workloads. And last point, which is to implement security and audit mechanisms. There are lots of third-party solutions that implement what we call the CSPM, which is Cloud Security Posture Management. Some of them are agent-based, some of them are agentless and allow you to have a deep discovery of your assets and identification of security misconfigurations that might happen at the OS level. So what's the value proposition of the AMI factory on AWS? So you can build once and deploy globally. You just need to think about your operational regions. And in one single execution of Packer through your CI/CD pipeline, you can distribute the creation of the AMIs in all of the regions where you are operating. And hence, there's no need for you to think about building the AMI in a disaster recovery region because you are already doing it from scratch. You obviously deploy in minutes versus days in weeks because you don't have to manually create AMIs in all of the regions. You do it only once for all. You can also enable your customers with tight integration with Terraform Cloud and Terraform Enterprise or even Terraform Community, in the sense that your customers and business and application teams, they don't need to hard code the AMI IDs in their Terraform configurations for them to be able to consume them. You just direct them to use a data source which interacts with the HCP Packer registry, and that's how you allow them to always be able to get the latest AMI. For some specific businesses that require to kind of use fixed AMIs for their workloads, there are mechanisms to solve that, and we will see that later. So improve operational reliability and auditability. So this is true because you don't need to think about building your AMIs each time for each region manually, which is a tedious process. You do it once with Packer, and everything is done through automation, so there is no your build is not subject to human errors, and you can also audit everything because of the logs stored in the CI/CD pipelines. And last element, which is super cool, which is that you can notify your customers of AMI events. You can even act upon that. For example, in case there is a zero-day vulnerability on a specific OS, you can simply deprecate this AMI from the HCP Packer registry, and it will have as a result through the integration, the custom integration we built, to revoke that AMI also on AWS accounts. What are the components of the AMI factory and how they are architected? So, in order to build the AMI factory, you need three components. The first one, which is Packer Community, which will be responsible for building the OS images in the AWS build accounts, which will be also integrated with the HCP Packer registry, which will act as a single metadata source of truth, and which will aggregate all of the OS images built across all of your cloud service providers or even on-premises. And then you have the consumers who are Terraform or Terraform Cloud, which will interact directly with the HCP Packer registry to fetch metadata about the OS images being currently used. And through some mechanisms, we can see whether if the OS image is deprecated or not, if it's revoked or not, and we can stop the Terraform plan ahead of time. So really, Packer is that abstraction layer which will make sure you can distribute your OS images across all cloud service providers. But we already spent some time on this. I just wanted to reiterate that. What's also cool with Packer is that you can, as part of the configuration, you can plug it with whatever mechanisms you have already to script and implement the hardening. So you can hook shell scripts with the runtime of Packer. You can hook PowerShell scripts or Ansible playbooks, as long as you have a mean to codify those hardening processes and make them available to the Packer configuration. How does the unified workflow work? So you have your set of template files in HCL. I think you can also use JSON, but recommendation is now to transition more over to HCL. Then as part of a CI/CD pipeline, you have your Packer runtime, which will scan through all of your template files, identify what are the plugins that are required, just like what Terraform does with Terraform init. Then what Packer will do is that he will trigger the build process, which will have as a result to spin an ephemeral instance. So in AWS, it spins an ephemeral EC2 instance, which will execute the sequence of shell scripts, PowerShell scripts, or Ansible playbooks that you provided in order for you to be able to implement your hardening and security logic. After that is done, the image is made available into the account, and you can also use some post-processing activities for metadata. But when you initiate the build and you indicate to Packer that you want to interact with the Packer registry, then automatically those metadata are being stored into HCP Packer registry. So let's quickly double-click on how does that work. As I mentioned, so Packer with HCL files builds the image, and after the image is being built, the metadata are being pushed to HCP Packer registry, and Terraform can query just some channels in HCP Packer registry to be able to get the AMI IDs programmatically, and then injects them into Terraform configurations for Terraform to be able to deploy the compute instances which are in AWS, the Amazon EC2 instances. Also, this is also a very cool event-driven architecture, in the sense that whenever there is an event happening in HCP Packer registry, you can trigger a webhook. This webhook will do whatever processing you'd like. So in the case of AWS, we've implemented a custom Lambda function, which will receive these events and will, for example, act upon the AMIs depending on the events. Again, for example, if you decide to revoke an AMI, then this AMI will be also disabled in AWS through this event-driven processing. And what's also really cool with HCP Packer registry is that they expose a webhook which allows you to consume AMI events or OS image events from HCP Packer registry and do whatever processes you'd like, as long as you have some compute intelligence. So in the context of AWS, what we did is that we plugged this webhook with a custom Lambda function to help us make our AMIs tidy in the AWS account, because you could have just revoked an AMI in the HCP Packer registry, but by default, HCP Packer registry will not go to the AWS account and tidy the AMIs or do anything you'd like. So these webhooks are really, really interesting because it allows you to automate the administration tasks also into AWS, on top of notifying your customers and telling them that there was a new deprecation event happening and that they have to fix it in their business and applications. So the HCP Packer Terraform run task is a native integration between Terraform Cloud and the HCP Packer registry, in the sense that you can simply go to your Terraform projects and enable the HCP Packer registry. What will happen is that whenever anyone will trigger a run of that Terraform configuration, Terraform under the hood, after the plan is done, will go and check the AMI metadata on HCP Packer registry and will take a decision whether to fail the run or not based on rules you define. So in general, HCP Packer run task is able to define whether you have hard-coded AMIs instead of using data source that gets them dynamically from HCP Packer registry. It can allow you to detect whether you are trying to deploy an EC2 instance using a deprecated or revoked AMI. And this is really super cool because it gives you this additional layer of control and security. So without further ado, let's start now with the demo and see all of this in action. So let's start with some code organization aspects. So my project is called SAP Migration Automation Factory. It contains multiple subgroups. So one for image as code, one for infra as code, one for config management, one for CI/CD tooling, and one for holding my documentation. So obviously all of my AMI factory is inside this images as code, but some prerequisites are also deployed as part of infra as code. And this is done via the following repository that I call Terraform AWS SAP AMI Factory Foundation. Of course, it has nothing really to do with SAP. It's just my naming convention. So of course, you are free to choose whatever you'd like for that. This configuration deploys a pair of KMS keys, one in my primary region and one in my disaster recovery region. These KMS keys will be used to encrypt the EBS snapshots, which will serve to build the AMIs on AWS. on both regions, and it also deploys AWS License Manager license configurations that I map also into inside my my Packer configurations to be able to keep account of my instances and how do I consume licenses. It also creates an AWS recycle bin resource, and this recycle bin allows you to protect yourself against mistaken deletions of AMIs or ABS snapshots, and also not mistaken but malicious deletions. You define a retention period, and if an AMI or an EBS volume has been deleted within that retention period, you could still go to the recycle bin and restore them. It also deploys HCP service principals for Packer. So this is a good practice because you want your Packer configurations to be able to talk with HCP with a dedicated service principal, which is not shared with other purposes. And also to improve the auditability of whatever you are doing. So that's pretty much it. Without further ado, let's start with AMI as code. So images as code, I have two subgroups, one which is called AMI as code and one for container images as code. So this is just to remind that Packer is also capable of creating container images and streamline them to AWS. But yeah, so our focus today would be on AMI as code. So here what I really recommend is that you create one project per OS version that you want to streamline as an AMI on AWS. So here in this case I have Oracle Linux, Red Hat for SAP, SUSE Enterprise Linux, and SUSE Enterprise Linux for SAP. So let's take, for example, Oracle Linux. So I create one folder which will hold all Packer configuration files, another one for Terraform configuration files, and I have a bunch of additional files just like my CI/CD pipeline definition. But the most important thing is also this config.yaml file, which injects the information into Packer and into Terraform folders, but we will see that later. Okay, so let's go a bit deeper. So in my Packer folder, I have all my .pkr.hcl files. So let's start first with our sources. So this is how to indicate to Packer what is the source AMI that Packer will be using to build all of your AMI. So in my case, I'm reading the Oracle Linux AMI from the AWS public AMIs. So this is an AMI that Oracle deploys in their own AWS account, and they share publicly to all their customers based on the partition where you are. So in my case, I'm instructing Packer to go and source that AMI using specific filters on a specific region, and I also specify to Packer where I want it to deploy the builder instance, which will be an ephemeral instance which will be used to create the AMIs. Here you can specify all of the specifications and attributes that you want the builder to have, like do you want it to have IMDS support for V2, which is a security good practice, to override the metadata options, what are the volumes that you want to map to the instance. And here, as you can see, I'm also mapping to the builder the license specifications that I want these AMIs to have when EC2 instance will be launched that use this AMI. You can also specify some tags. And here the cool thing is that you can also create another source, which is this time going to be your disaster recovery source, which means it's basically exactly the same as all what we saw. The only difference is that the region in this case is mapped to my variable disaster recovery region. This allows me really to have two different sources on two different regions in one shot, right? In case you are in a multi-cloud service provider strategy, you could do, I would say, the same with other cloud service providers using the different source files from Packer documentation. Okay, so before we talk about the builder, let's have a look at the provisioners folders. So the provisioners folders is something that I decided to implement, which is to split the different shell scripts and configurations that I want to apply to my builder in specific folders. So for example, whenever there is something specific to AWS, I'm putting it in AWS. As you can see, I have shell scripts to install AWS CLI, to install the AWS CloudWatch agent, to install the AWS data provider for SAP, the SSM agent, and some AWS utilities. I also use this OS folder to do all whatever configurations that are specific to the OS, like the implementation of the OS banner, the installation of security agents like threat optics, installing Ansible, setting up cronny, and implementing the EBS-NV mapping, for example. I also have one specific folder which contains all the, normally it's supposed to contain all the security hardening scripts provided by security team or by the customer. So in my case here, in my demo, I just have a banner, but it follows the same principle. Of course, here I'm talking about shell scripts, but keep in mind that Packer can also trigger Ansible playbooks in case you have those handy. So after we talked about provisioners, now let's dive a little bit deeper into the builder. The builder will rely on plugins. So in my case, I am deploying AMIs and images on AWS, so I'm using only this plugin. But in case you are in a multi-cloud service provider, you can specify the other cloud service providers plugins that are made available by Packer. So I have this build attribute. So I mistakenly will not talk about this first. I will talk about it later. In this build object, you specify the description, and you can also specify your sources. So here I'm checking on this conditional whether I am on a disaster recovery scenario or not. Here, if I am on a disaster recovery scenario, then my builder will instantiate two builders, one on the main region and one on the disaster recovery region. And if not, it will do only the primary region. Then inside that, you specify these provisioner dynamic blocks. So each time you specify a provisioner with the type file, Packer will copy those files that are available in my repository into the /tmp of the ephemeral builder. And it does that for all of the files that I have. Shell scripts. You could also do something more elegant, like by asking Packer to copy all the files of a specific folder recursively, and then you specify the provisioner which will run your logic. So in my case, I'm using, to keep it simple, a provisioner of type shell that will execute all of these scripts in sequence. And so this is where you would be putting your logic to harden your OS as per your company security guidelines. And here I'm setting expect disconnect to true because sometimes I need to do some reboots of the ephemeral instance. I don't want Packer to consider that the build failed, so I'm setting this expect disconnect to true. So all of that said, this is pure standard Packer, nothing specific to HCP. Okay, so in order to integrate with HCP, you just need to add this block to your configuration, which is the HCP Packer Registry configuration object, where here you specify a bucket. So in HCP constructs, bucket is the name of an OS container, an OS container where you put all of your OS metadata. You can provide it with a description, with some labels, which are like tags. After that, I have some locals for some constants within my my configuration, and as you can see here, I am sourcing the HCP Packer Registry bucket name from a YAML file which is in the root of my project that we will be seeing in a few seconds. I also have my variables, which allow me to expose elements outside of my configuration, and I also have my inputs file where here I created these pkrvars.htl after the names of my branches. So I have my development and production branches, and inside each one of these I'm specifying the name of the company for the OS banner, whether do I want disaster recovery or not, and some elements about what we've been discussing. I also specify here the filters for Packer to be able to find the source AMI that we were talking about. So in my case here, I want to harden an Oracle Enterprise Linux 8.8. So I'm giving this search string to Packer for it to find the latest AMI. And here in source AMI owners, I specify the AWS account ID of Oracle account, which this information is public, which allows me to make sure that I'm grabbing only the AMIs that Oracle delivered and not someone who might spoof Oracle for that. I'm also specifying some details about which instance type I want my builders to use, what is the end of support date. So this is really interesting because before I ever build a hardened AMI on Oracle Linux, I first get the date by which Oracle is stopping the support of this specific version, and I'm putting it here. And this will make sure that whatever hardened AMI I will be launching with this image as a base, I will keep the same end of support date. So now that I'm connected to HCP, let me show you how the Packer registry looks like. So here I have a bunch of buckets. As you can see, you cannot create buckets directly from the console, which is good because it means that buckets can only be created from a Packer execution. So let's take, for example, the Oracle Enterprise Linux and simply delete it, right? I will delete it now. Let me delete all of those. Now, after I deleted I cleansed a little bit. So now if I want to create a new Oracle Enterprise Linux image to be tracked in HCP Packer Registry, I simply need to run my pipelines, and this is what's going to happen. So if I go now to my Oracle Linux repository, if I trigger my pipeline if I trigger my pipeline like this. So I'm gonna run it in the development environment. So my CI/CD pipeline takes a bunch of parameters, but there are mainly two important ones. So do you want to run Packer? So I set it to true. Do you want to run Terraform? I set it to true. Do you want to destroy? No, I don't want to run a Terraform destroy. And as you can see here, there's this HCP Packer registry environment variable which is set to 1. So here I'm gonna click on run the pipeline. So in order for Packer to be able to integrate with HCP Packer registry securely using the credentials that I created via the AMI Factory Foundation's Terraform project, so I defined some GitLab CI/CD variables in the images code project. So if I go here to settings CI/CD, you will see that I have in my variables created 4 environment variables: the HCP client ID and client secret, which are coming from my foundations. Then there's the project ID, which is basically a constant, and the Packer config dir, which specifies to Packer from where to initialize the plugins, right? So that's pretty much it. Let's go back now to the pipeline and see what is it doing. So my pipeline is very lengthy, I would say, because we DevOps people, we like to have multiple security gates. So my first step is called Packer init, which is allowing Packer to discover all the required plugins and to download them, similar to what Terraform init is doing. Then I have a Packer format to make sure that my Packer configuration is correctly indented and follows the style guide recommended by HashiCorp. I have Packer validate to make sure that my Packer configuration is syntactically correct. I also have some shell checks to make sure that my shell scripts do not contain buggy or insecure instructions, and same for Ansible lint in case I used Ansible configurations to do the hardening, for example, or whatever installations that you want to do in order to make sure that your Ansible config is fine and secure. Then I have the Packer build process which run. So let me open this. So as you can see, it's gonna spin an EC2 instance, which will have a temporary security group of 0.0.0/0 on port 22. So of course all of this is like default behavior. You can restrict this even more as part of your construct. It's just that in case my GitLab runner needs to connect to my instance via internet, that's why I'm doing that. But in a context of a company, you can deploy your runners in the same account, ephemeral runners on the same account, and have like a connection from within the account without the need to open to 0.0.0/0 on SSH port. Then it's triggering an ephemeral instance with all of my specifications. As you can see, it was able to land on a specific version of the Oracle Linux 8.8 AMI. I think it's the version from 21st of June 23. It contains all of the tags that I asked it to do, and as you can see, it's the color code in here is green and blue. So the green is for all what's happening in my primary region, and in blue it's all what's happening in my disaster recovery region. And then after Packer instructs AWS to spin that EC2 instance, it waits until it's ready. And after it's ready, it attempts to connect via SSH. And after it connects via SSH, it starts uploading my files one-to-one into the /tmp. And then after that, it starts doing the processing. Okay, in the meantime, I can probably explain. So what's really cool about HCP Packer registry is that it allows you to have webhooks. Right? This is something which is still in beta, but I really love it. So in order to find the webhooks, you need to go to project settings here, and you go to webhooks, and here you can create a new webhook and give it a name, a description, and of course you need to provide the webhook URL and a token. And here you can subscribe to specific AMI events, like whenever a new version is created or completed, or revoked, or someone schedules the revocation of a version, or cancels the revocation of a version, or restores it, or deletes it, or assigns a version to a channel. So all of these events can be very meaningful to your business and application teams, and this is what I hopefully will be demoing to you too today. There is also something super cool that I was telling you about notifications. So as you can see here, I have created we will talk about that later, but I just triggered the pipeline like 5 minutes ago, and I was able to receive a notification which tells me, oh, there is a new creation event of the Oracle Enterprise Linux, which is running actually, and this is really cool to be able for you to communicate to your business. So now if we go back to HCP Packer registry, and here if I refresh my page, you will see that now I'll have a new bucket for Oracle Enterprise Linux, which will show up here. And as you can see, there is no parents, no children, and there is no version for now because we are currently building it. And if you see the versions here, you will see that there is a currently running execution, which is incomplete, and it's waiting for the build to finish in order for it to store the metadata. So in the meantime, let's go and check what's happening. So if I open my instances, as you can see here, there is this Packer Builder instance which is now stopped. So after Packer created that ephemeral instance and run all of the shell scripts I instructed it to do, it stopped the instance, and now it's in the process of creating an AMI out of it before terminating that builder instance. So all of this is really automated and streamlined to make sure it's really cost effective and does just what you want, which is to create the AMI on AWS. And if I am to go on the Frankfurt region, you will see that it's exactly the same process happening. The instance is now stopped, and it's being consistently created. The AMI is being consistently created across the two regions. All right, so as you can see here, now the source instance was stopped, the AMI got created, and now it's enabling the deprecation on the AMI to match exactly what I found in Oracle source AMI to make sure that I keep the same deprecation date. Packer is then applying the tags to the AMIs, and then it's terminating the source AWS instance, it's cleaning up the volumes. And now if I go back to here and I refresh, this instance should be now terminated. And if I go here to Frankfurt region and I refresh, it's also in the terminated state, which concludes the fact that my build is successful. So let's give a few minutes to the pipeline to finish. Okay, so as you can see, my job is now finished. So now the pipeline will move to the Terraform chunk of it, which is to set the channels that I defined, because by default, if I go back here to the Packer registry, my Oracle Enterprise Linux build is now active. So I have one version which is active, and it's mapped to the channel called latest. And this channel, in fact, is managed by HCP Packer, which means that you cannot delete this channel. You can edit who has access to it, but you cannot delete it. It's something that HCP will always maintain for you. So whenever you create a new version, that new version will be mapped to the latest channel. But as I was explaining, sometimes your business doesn't want that. So in order to mitigate that, I'm creating with Terraform my channels that I want my business and application teams to use. So I'm here. I have. Let me open this a little bit in big, so it's going to be easier to explain. So I have my Terraform init, I have some quality gates around my Terraform code. As you can see here, it will create one new channel that it will be called development, and will map the version that I just created. And now if I manually approve the apply, I will just specify yes that I want to approve and run the job. It will go back to the registry. If I go back here to the registry and I refresh after a few minutes, so my Terraform plan failed. I don't know what's happened with the assignment, but here I just rerun my plan again. I think it's a bug with the HCP provider, where it's not able to create a channel and an assignment at the same time. So you have to do it in sequence, create a channel, then first. So maybe I will raise an issue to the product about that. But here, if I rerun again my plan, this time hopefully it should work. So now my apply is running, and as you can see, now if I go back here and I refresh, this time the channel is not only the channel is created, but also it's mapped to the version number 1. And in case I want to distribute the version 1 to some specific people in dev, I can use this channel. And in that case, what I will do then is I'll go back here to my pipeline. I will create a merge request where I will say I want to merge my development into my production, and I will merge it.
Then I will execute my pipeline in production, which will help me create the image in the production that will be used to share the AMIs to the target accounts. So in my case, since I have only one account, it makes no sense to recreate the AMI because it's already there. So I will just run Terraform instead of running Packer again. So this will have as an effect that it will just create the production channel. It will just create the production channel and version and map it to the version rather than creating the AMI. With that being said, I forgot to tell you about the notifications. So as you can see here, we got lots of notifications. So the AMI was the version, the Packer version creation happened at 11:53 CET on the 3rd of February. There was a completed event caught by the webhook. As you can see, it was able to tell me when the build was finished, so it took about 16 minutes to complete the build. Now I have my iteration, which is version 1. I can from Packer see the AMIs that I can use. I can even click on the links for me to be able to see the AMIs. So as you can see, my AMI with my naming convention is there. It has the deprecation time, which is the 13th of June 25. You can see here the permissions. So here, as part of the demo in Packer, I'm not specifying any accounts with whom I need to share this image, but this is what you should do from your OS build images. Don't copy the AMIs, because by copying the AMIs, you create a segregated object that has its own lifecycle, but by sharing it to the other accounts or other OUs, you can keep control from this build account, because in case there is a vulnerability or something, or you want to deprecate this image, in this case you just need to unshare it from the accounts or OUs, and your businesses will not be able to use it anymore. And this is what makes this really effective. Then we have our storage that are using the KMS key accredited in the foundations, and obviously some tags. And if I click the second link, it would open the AMI on the disaster recovery region, which is Frankfurt for me. And as you can see, the image is also there with the same naming convention, and it's encrypted with GP3. Okay. What do we have as notifications? So we also see that there was a new version which was assigned to the channel latest. As you can see, the V1. There is no old iterations or old AMI IDs because it's a new build, right? And as you can see, also there was an assignment of the version 1 to the channel development, and also there was no old iteration or old AMI build. Otherwise, the notification would have given us that information. Okay, so let's go back now to our pipeline. Let's execute it here. If I go to my pipeline, as you can see, this has happened. So if I go here to my Packer registry and I hit refresh, you will see that my production channel is now created, and the same bug, so I need to rerun it again. Yeah, as you can see here, the version will be set to 1. So if I rerun again my apply, it should be good to go. Here my Terraform is applying. Now the assignment has happened. As you can see, at noon 25, I have now my production channel created, and the version is assigned now to V1. And in parallel, let us introduce a change in our YAML config file and say, for example, we want to create version 2 in the development, right? Here, let me, sorry, I'm using aliases, commit messages, increment the dev version. Here I'm running my pre-commit hooks to make sure that I have the same guardrails as in my CI/CD pipeline. This is a good practice. And let me run a git push. This way I can initiate the creation of the version 2. Okay, so let's run a pipeline again for our second version. So let's make sure we are in the development branch. And in this case, let's select run Packer to true. Let's set run Packer to true. And run Terraform also to true. And let's run the pipeline. And this time it will create our AMI version 2 on AWS. So the pipeline is running. Let me pause here and see what happens. So let's go back now to our image. So we have two versions. version 1, version 2. We have the channel's development and latest assigned to the version 2. And now, how would your business and application teams consume these images, right? So for them to be able to do that, they just need to go to the bucket. And here you can see HashiCorp has prepared some quick links for you to be able to generate code snippets allowing you to do that. So in case you'd like to use this AMI with Terraform, you just need to select the channel, the platform, and the region. And by default, you will be able to copy this snippet and be able to use it in your configuration. And same is in case you want to use this image as a source image for another Packer image. You could use this data source. Of course, there are documentation links which would allow you to dive a little bit deeper. Okay, so let's imagine, for example, there is a vulnerability in the AMI v2 and you want to deprecate it. So in order to do that, you just need to go to the HCP Packer registry, go to manage, revoke version, and you can probably give it a meaningful reason for your business to be able to follow along with you. So you can say this AMI is vulnerable to CVE 1, 2, 3, 4, 5, 6, for example. You can also specify a revocation time. Either you want to revoke it immediately or at a future date. So in my case, I'll choose, for example, to revoke it immediately, and I'd like also to specify how I want my channels to behave in the case of revocation. Either I want to roll it back, to roll the channels back or not. So in my case, I will select yes, but before doing that, I will just open the AMIs on the console for you to be able to see. So I can do that by clicking the links directly in my notifications message. Alright, so before I hit revoke, let's see the details of one of the AMIs. So let's take the one in Dublin. As you can see here, the AMI is has a deprecation date which is the 13th of June 25, which is the default deprecation date that the OS provider provided in this case. So now if I revoke the AMI, what will happen? Let me revoke it now. So as you can see in the UI here, I can see that this has been revoked by myself, and the reason is this AMI is vulnerable. Alright, so if I go back here to my notifications, you can see that if we take, for example, so this is the message which told us, okay, so if we take here, so if we take our notifications, we just receive a notification to let us know that the new iteration version is v1 and the old iteration is v2, which means that the rollback worked. We went from v2 to v1 on the channel latest. We also went back from v2 to v1 on the channel development. And we didn't do that in production because remember, production was still in v1, right? You can also see that we have received a revocation event which says that v2 has been revoked because it's vulnerable to CVE 1, 2, 3, 4, 5, 6. And that this impacts the cloud provider AWS and the following AMIs. And if now we go back to the AMIs, if I refresh here, for example, you will see that the deprecation time has changed from 13th of June 2025 to 1 minute ago. As you can see, it's like noon 49 CET, and this means that now this AMI is deprecated. It's not going to be visible to people who do not know the AMI ID. And same happens for the disaster recovery region. So here, if I open the details, you will see that I still need to refresh here. So yeah, deprecation time is February 3rd. All right. So what happens if I want to restore? So you notice also that when I deprecated, in fact, I set the old revoke at date in a specific tag on the instance, which means that if now I decide to restore my AMI, then Packer will be able not only to restore and set all the channels back, as I just showed you here. Let us see the notifications. So now it says that it has assigned the latest channel from v1 now to v2. As you can see now, we went from v1 to v2, and the AMI has been restored, which is v2, and we still get the AMI. So now if I go back here to the images and I refresh again, you will see that my deprecation time went back again to the original date, which was 30 of June 25, both on both regions. So let me refresh here. Yeah. Exact. Now that we saw the process for revocation and restoration, we can also revoke version 2 on a later date. So let's do revoke version and say this AMI is vulnerable to CVE 12345 let's put a dash here, and in this time let's revoke at a future date, and we can say, for example, today, and as you can see here they give you, okay, let's put here 11:55 AM UTC. Let's revoke the AMI, and you can see here the image is not revoked yet. It's scheduled to be revoked very soon. We are going to get also the notifications via Slack. So by refreshing, we can see that this AMI has been revoked, and we follow exactly the same process. So we can see that notifications says that there was a new revocation which happened on V2 because this AMI is vulnerable to CVE 123456. It has been the channel has been moved now to V1. It was V2 in the past, and the version 2 has got revoked. All right. So now if we go back here to the versions, you can see that the channels, you can see that everything is mapped now to V1. And if we go back here to the AMIs and I refresh again, you can see that the deprecation time is again set to like a few seconds ago. Here, if I refresh again, a few seconds ago. Issue with revocation is that anyone who has access to the AMI ID or wants to list the AMI and set a specific flag in the AWS API to say, I want to see even deprecated AMIs, will be able to consume the AMI. So if you want to make sure to really prevent anyone from using it, you have to delete the AMI. And in order for you to be able to do that, you just need to go to HCP Packer Registry, select the version that you want to delete, and you can just click Manage Delete Version. And here, if you click Delete, if I simply refresh, as you can see, the AMI is not there anymore. And if I go to Frankfurt and I hit refresh, the AMI has been deleted. So it's really, really powerful to have your single point of control for all of your AMIs within HCP Packer Registry. So in order for us to be able to see this in action, I created a small repository called HashiTalks 2024 demo. Basically what this module does is that it deploys an EC2 instance, and in the AMI it takes either an AMI ID provided as a variable, or it reads the data source from HCP Packer Registry. The data source is available in the data.tf file, as you can see here, where I am reading the image based on a bucket name and on a channel name, right? So let's deploy this with Terraform Cloud. So I'll go back to HCP. Let me click now on Terraform. This will open Terraform Cloud from HCP UI, and from here I'll go to Registry, and I will publish a new module, which is coming from GitHub, from my private repo on GitHub. I will use tag based, and I will select this module to be able to be provisioned via no-code provisioning. So I will just publish the module. And here I want to show you a couple of cool things specifically regarding to the HCP Packer run task, which is a webhook that Terraform Cloud uses to interact with the HCP registry to validate that your users are doing the things right. Alright, so now that I created this module, let me provision a workspace from it. I will call it HCP Packer AWS AMI Factory Demo. Let me select the project being events. Let's not put a description, and let's set the apply to be manuals. Let me create the workspace. So as soon as I created this workspace, let's go to settings, and let me show you these run tasks. So I created this run task, which is called the Acme HCP Packer run task. So in order for you to be able to enable the HCP Packer registry integration with Terraform Cloud, you just need to go back here to the buckets and select integrate with Terraform Cloud, and it gives you an endpoint URL and an HMAC key that you can use to authenticate Terraform Cloud with HCP Packer registry. So if we go back now to here, so you go to the settings of your workspace, general settings, and you go to run tasks, and you create click create a run task. Here you give it a name, description, you provide the endpoint URL that you copied previously from HCP Packer registry, and the HMAC key. So there's no need for me to do it because I did it already in the past. I just wanted to highlight also that I implemented a another run task, which is for Orca Security Platform, which is allowing me to do all my shift left discoveries to make sure that my Terraform configuration is compliant with security best practices. So now let's go back to the workspace and open this run. So obviously after I created the module, I had the first run by default, and this run is in error because I didn't specify required variables, like there is no AMI and things like that. So let us fix this first by going to settings and enabling the run task. So I'll add the HCP Packer Registry run task. I'll make sure it is in post plan and it's mandatory. Which means that failed run tasks will stop the run, and advisory, it accepts that this fails, but you would like probably to make this mandatory, right? And we are going to do the same with Orca shift left. I'm gonna put it in post plan and make it mandatory to make sure that it stops me from moving ahead in case there is a failure. Then I'll go to my root level, I'll go to the variables, and I'll add a couple of variables. So here, in order to show you the warning that you get in case you are using an AMI which is not tracked as part of a HCP Packer registry, let's put the variable AMI ID, and here I put AMI ID equals to this. Let me add the variable. Let's trigger a new run and let's call it hard-coded AMI ID. Let's start the run, and you can see here my run is ongoing. So there are 27 resources to create. So the objective is really not to, it's very basic deployment. There's nothing fancy about it. Then as you can see, I have this post plan running, and if I go here to all, there are my two tasks, run tasks that are there. So as you can see, if you click the HCP Packer run task, you see that there is a warning. It says that this Terraform configuration is using an AMI which is not being tracked as part of HCP Packer registry, which means that it's not a good practice, right? Because it's probably that your business or application team here is using an AMI which is not hardened, which is not what you want, right? So with this very cool feature, you can easily see the Terraform configurations that do not comply with your security standards. And also, what's really cool with shift left is that not only you will be able to discover vulnerabilities beforehand, but before you deploy your infrastructure. So as you can see, my configuration here is not compliant. There are 7 issues. So if I want to click, I can click more details for me to be able to see the issues with this build. So obviously the objective is not to go through all of these. Sometimes, for example, you want to deploy instances with public IPv4 by design, but I just wanted to show you that you can go very deep into scanning your assets before you deploy them actually on AWS, and you can do this with Orca Security Platform, of course. So let's go back to our run. Now that we saw that HCP Packer run task was able to identify that our instance was not tracked as part of HCP Packer registry artifacts, let's go and modify the variables, and this time instead of using an AMI ID, let's add a new variable. Let me copy those from my code to avoid any typos. Alright, so I called it HCP Packer registry bucket name. So if I go here, let me put this here, and I put the value of OEL x8664, and let me add another variable, which is the channel, if I'm not mistaken. Yes, let me add the channel, and here I will say that I want this to go to use the development channel, right? Let me add this variable, and ultimately I will just delete the AMI ID. So before we execute the run, let's see. Remember, the channel development is assigned to the version number 2, okay, which is the latest version, which is good, right? So now if I execute my my run again, so using latest version from Packer registry using HCP Packer registry data source, right? So here, let me execute this run, and let's see if the run task behaves differently, right? Okay, let's see our run tasks now. So as you can see, our run task for Packer already completed, and it's already saying that it's up to date. My configuration is using the latest current and approved artifact, which is good because it means in that case that my business or application team is using an AMI which is hardened as per my standards, and they can safely. You can consider that the OS based configuration would be safe, and that's why I really tell you that I really want to reinforce that you really need a real shift left strategy, because this is not enough. Making sure that you are using hardened OS image is not enough. Probably someone can make a configuration mistake in Terraform. So that's the reason why this shift left is still important. Let's now, for example, head back to the registry, and instead of mapping the development channel to V2, let's move it to V1 to see what happens in case you are using a version which is like below. So let's use the V1. Let's update the channel, and let's go back here and execute a new run. And in this case, I'll call it using an AMI, an outdated AMI, using an outdated AMI. All right. So what happens now? So again, the Terraform plan should be consistent with 27 resources. Yes. Let's try to see our, okay, so our HCP Packer run task run, and as you can see, it identified that V1 is really tracked in HCP Packer in the bucket OEL, but it's out of date because there is a newer version available, because this means that probably your business needs to act upon the assignment of the channel, or that at least it gives them indication that what they deployed is good, but not good enough in the sense that there is a newer version that they can use, right? So this is cool. Now let's go back to the bucket, and let's manage the channel development and assign it back to V2. Edit assigned version. Let's set it to V2. And in this case, let's go back to the bucket and revoke the version number 2, right? Okay. Let's go here and try to schedule this revocation. And let's not roll back the channel. So let's say, for example, we want to revoke it. This AMI is vulnerable to CVE 1, 2, 3, 4, 5, 6. And here, let's say, for example, in 1 minute, which is 58. And let's not roll back. Oh, 58 PM. Okay. Up. Oh, 58, it's too late. Say 59. Right, so now if I go here to channels, you can see that my development and latest, they are mapped to revocation that's gonna be happening in a few minutes, in a few seconds. Okay, so as you can see, the AMI got revoked. Now let's go and check the channels. As you can see here, the channel development is mapped to a version which has been revoked. So the test we're gonna do now is to trigger a new run, right? And say revoked AMI. And in this case, let's see what the run task says. So the plan is still consistent with 27 resources to create. Let's see what the plan says. So as you can see, this time the HCP Packer run task is failed, and the failure reason is because this V2 in HCP Packer bucket OEL is revoked. So to reduce any security risks, this run task failed the execution, which means that even if your business has is trying to keep using this AMI or to do whatever, their plans will be blocked. This way they can take action. Of course, I still have my Orca shift left run task running, which will fail too, but yeah, that's really what I wanted to show you. So 3 use cases. If we do a quick overview of the runs, we run with hard-coded AMI. We got a warning because the HCP Packer run task does not block you from using a hard-coded one. We used the latest version from HCP Packer Registry using the data source, and this time it told us that everything was fine. Then we used an outdated AMI in the sense that we revoked version, we mapped the channel to version 1 and we kept version 2 live. And in this case, we got a warning that we're probably not using the most recent one. And last thing is that we scheduled the revocation of an AMI on a future date without rolling back the channels. And in that case, we were in a situation where our channel was pointing to a revoked AMI, and then when we triggered the run task, it simply failed because the AMI is revoked, and which is highly likely to be because it's unsecure.
So that was pretty much it for me. I hope you liked the content. As always, please feel free to reach out to me on LinkedIn in case you need anything. I also included the link for you to be able to schedule deep dive meetings with me in case you want to get to know more about how we can implement this within AWS. There is also a link for you to be able to provide me with feedback. Please feel free to tell me what you liked, what you didn't like, things that can be improved on my speech. And last thing is, as you know, HashiCorp has local user groups, so I added a small link for you to be able to find the local hug nearby. And looking forward to hearing from you, and au revoir, bye.